All right, samples and experiments going through this video. Correlation does not prove causation. Just because we see something, we might see, we've used this one before, the weights of elementary kids. As the weights go up, we see the reading level go up. Okay, we might say, really? The weights as reading level goes up? Yes, because a first grader is going to weigh less and they're going to read at a first grade level. A second grader is going to weigh more because they're growing and they're going to read at a second grade level, up to a bigger kid at, let's say, fifth or sixth grade, wherever you want to call elementary to be. So the correlation doesn't mean that the weight causes the reading level. So if it did, then let's gain more weight or something like that. But that's pretty true all through human history, that the more you weigh, the higher reading level you're going to be eventually, until you get to be everybody being adults. Then once you're fully grown, it's not going to be the case. But since we're talking about elementary kids, you're going to see a correlation there. There are different types of samples. Okay, but coming back to that first point, remember, it's not automatic that you see a correlation, that X causes the Y. All right, types of samples. A sample where every group of N has an equal chance to occur. We call that an SRS, or a simple random sample. How do you do that? You put everybody's name, you put them in a hat, you shake the hat, and that's what you would get. Sample that selects some from each group. This one is called a stratified sample. Okay. So how do we do a stratified sample? We sample 10 of the freshmen. We sample 12 sophomores, 8 juniors, 8 seniors. Maybe our sophomore class has a few more. Maybe that was matching stratified. But when you're sampling from each of the groups where they're separated, that's stratified. This one, select groups randomly. And I'm using the example of grapes. This is the cluster sample. Okay. So what's the difference between stratified and cluster? In this one, you have these groups that are all different. Freshman, sophomore, junior, senior, and you sample a little bit out of each of them. In the cluster sample, they're mixed up. You've got buckets of grapes. Maybe you got this truckload and it's got, let's say, 500 buckets, and you randomly pick 3, and then you just take those 3. You take everything. That's a cluster. You take the whole cluster because it's mixed up in the same way. So you got to recognize when you should stratify and when you should do a cluster. That should be something you're thinking of. Random sampling every nth person, that one is systematic. Okay, so every nth person, every 7th person that walks in the room. I survey the whole population. That one we call a census. Okay, so you got to know those names. You got to know kind of how to do those. You might be asked, how would you perform a simple random sample? A simple random sample, you might say, we're going to put all the names in a hat. We're going to draw 6. That's a simple random sample. How could you do a stratified sample? We'll pick a starting number from 1 to 10 or 1 to 12 or whatever, and then we're going to survey every 10th person, every 12th person, something like that. Got to be able to explain those. Now, a well-designed experiment, it should compare comparisons of at least 2 treatment groups. One is control, so you have what we call the control and the treatment group. A lot of times we're talking about like a drug and a placebo. Placebo, remember, is something that it is known to have no effect. You need random assignment. If you don't randomly assign them to the groups, you're using personal selection. You're going to bias that experiment. You need replication. Should be multiple people in groups, but potentially you might need multiple locations. Maybe an experiment on plants works well in Florida, but it doesn't work well in South Dakota because the climate's different. Okay. That's supposed to be an O. You control potential confounding variables where appropriate. We can have things, if we go back to our first thing, there's a confounding variable up here. Confounding means confusing. And it's really the age of the student that is causing, because as you age when you're in elementary, you're going to weigh more. As you age, you should read better because you're getting older, as long as you're studying and doing stuff. Okay, so these are some old AP test questions. I know they're kind of small, but you should have the printout in front of you. Hopefully you can read that. These are old AP test questions that deal with these things. Okay, one thing we didn't talk about, experiment, observational study. Let's get that down quick. An observational study and an experiment. What's the difference? You assign people in an experiment. Observational study, people choose which one to participate in. So that's something you have to remember. Okay, so we have this. The dentists in a dental clinic would like to determine if there's a difference between the number of new cavities in people who eat an apple a day and people who eat less than an apple a week. They're going to conduct a study with 50 people in each group. All right, we got to read. Are they going to assign it or do people get to choose it? It says 50 clinic patients who report they routinely eat an apple a day. So these people, they report they do it. They're choosing to do it on their own. And 50 clinic patients who report they eat less than an apple a week will be identified. They'll examine the patients and their records to determine if the number of cavities they've had over the last 2 years. They'll compare the number of new cavities in the two groups. Is it observational or experiment? We know that it's observational study. And the reason is the patients chose. They weren't assigned to eat the apple. Explain the concept of confounding in the study. Include an example of a possible confounding variable. Now, on this, just to be clear, if this was an AP test question, that part A, it would give you a lot of space to write. Okay, this is condensed and squished in just because I printed these and could get them on 2 sheets of paper, front and back. But you'll have a lot more room. So you might want to have another sheet of paper, or else you're going to be writing around this thing however. So if you have a sheet of paper, you can do that. Okay, the concept of confounding in the study, they chose. So, all right, you need to come up with another variable. Here's an idea. Maybe those that eat well also exercise or brush their teeth more. I gave 2 potential confounding variables. Okay, so exercise, maybe exercise gets your blood flow going and it reduces your cavities. Maybe brushing your teeth more reduces your cavities. Okay, so the confounding variable, you want to explain the concept here that it could be the exercise or the brushing of teeth. I'm not going to write all that down. You want to listen to this. It could be the exercise or brushing the teeth that causes them to have fewer cavities. And it's because they choose to eat better, eat the apple a day. They also choose other things that could be causing it. When you don't assign it in the experiment setting, you can't say that it's cause effect. We may see a correlation, but correlation isn't necessarily the cause effect. All right, if the mean number of new cavities for those who ate an apple a day was statistically significantly smaller than the mean number of those who ate less than an apple a week, could we conclude that it's contributed or attributed to that? No. Since it wasn't an experiment cause effect can't be determined. Okay? So because it's an experiment, cause effect can't be determined. All right, number 2, manufacturer boots plans to conduct, I think we did this one during the year. Manufacturer boots plans to conduct a new experiment to compare a new method of waterproofing for the current method. The appearance of the boots is not changed by either method. The company recruits 100 volunteers in Seattle, where it rains frequently, to wear the boots as they normally would for 6 months. At the end of the 6 months, the boots will be returned to the company and evaluated for water damage. Now, this is a pretty old question, but it's got some good key points for thinking of. Okay, if you are wearing boots or wearing gloves or doing something like that, where you have 2 hands, 2 feet, then you have the option to make it matched pairs, because we can put one type of treatment on one foot and one type of treatment on the other foot. And that's really what you should do. So we take the 100 volunteers. Now this is part A. You can make a diagram. Our 100 volunteers. And when you're doing this, remember, you always want to say randomly assigned. Going back to the principles of good experiments, we randomly assign. That was one of the 4 principles up top. Now we need some replication. So we're going to have 50 people here and 50 people here. We've got replication. Now we need a control group and a treatment group, potentially. This one, there's not really a control group in the sense, I guess there is. It's the old method is the control group. So pardon me. But 50 will wear the old treatment on, now you have to pick one, on the left shoe. And the new treatment on the right. And then the other group, they get the old treatment on the right and the new on the left. So we've got 3 of those principles in here that we mentioned. We're comparing at least 2 treatment groups. One is the control, it's the old treatment, one's the new. We've got random assignment. We've got replication. Now, any potential variables, we actually did control potential variables in there, because we controlled the idea of whether your more dominant foot is your left or your right foot. So we are controlling some variables in there. Now, there's one thing not mentioned, that you should have a time period. Well, they gave us the 6 months. If they don't give you a time period, then you make one up. You say after an appropriate amount of time, because sometimes students don't know, well, should it be 3 weeks, 5 minutes? I mean, if you're testing a headache medication and they take the drug and the placebo and then you test them immediately after, it probably didn't change. You probably have to have several hours. So learn to say after an appropriate amount of time. If they give you a time period, put it in there. We are going to compare something. We're going to compare the wear on the boots. Okay, we're going to see which one is better. Now, when this test was given, the thing they did, there were a lot of students who got half credit, because they assigned 50 of the people to get the old treatment on the right and 50 to get the new on the left. Look for things that have a natural pairing. You have 2 hands, we can put one treatment on the right, one on the left. You have 2 feet. It doesn't work the same with eyes, because you're not going to do like one new contact in the right and one new contact in the left, because that could potentially make you dizzy or something like that. And probably ears too. There's stuff with their balance that things don't always work. So look for natural pairing. Could our experiment be double blind? Ultimately, for B, it's looking for a definition of double blind. If you remember, this one is yes, because the subjects, since it says in here that it says the appearance of the boots is not changed by either method, the subjects won't know. There's 2 groups that have to not know. It's the people doing it. So if you're taking a drug and you got a placebo and a pill, they should look the same, so you can't tell them apart. But also the evaluators the people who evaluate the wear and tear could be unaware as well. See, now somewhere somebody's got to know. Somebody's got to have the master spreadsheet of who got what. But if they're involved in evaluating, then it's not double blind. All right. At a certain university, students who live in dormitories eat at a common dining hall. Recently, some students have been complaining about the quality of food served there. The dining hall manager decides to do a survey to estimate the proportion of students living in the dormitories who think the quality of food should be improved. One evening, the manager asked the first 100 students entering the dining hall to answer the question. Many students believe the food served in the dining hall needs improvement. Now, right away when you say this is common today. I mean, if you watch news media and stuff, there are so many news medias, they just automatically incorporate a bias in things. The food needs improvement. They're saying that right away. Okay, they're against something. They're not about preventing or asking something with a fact. They're telling you that the food already stinks. Okay, do you think the quality of food needs improvement, even though that would increase the cost of the meal plan? So there's a second thing involving that. They actually sway this one kind of both ways, and then it says yes, no, no opinion. Okay, the better question would have just been, do you think the quality of food served here needs improvement? Then you're going to give an honest answer, yes, because I think it's not good enough, or no, because I like the food. But there's two things trying to sway you. There's a lot of people who say it's bad, and then, oh, that'll increase your meal plan. So it's actually trying to pull it both ways, but this is a bad question. It's explain how bias may have been introduced based on the way the convenience sample was selected. Okay, so now they're talking about the convenience sample. Okay, some students have been complaining. The dining hall manager did a survey of the proportion of students living in dorms. He asks the first 100 students. Okay, so you do have to know, what is convenience sample? Convenience sample is about who's convenient, who's right there. So you have to figure out with this one. This one has nothing to do with the question. This question is about, it's the first 100 students. If you're the first 100 people into the dining hall, you probably like the food, okay? Because you're there first. You're like, I'm hungry. I'm going to go eat. It doesn't bother you. You're not the people dragging your feet to get there. So I think that there will be more no answers, because they're going to answer no to that question because they're going to say, well, it doesn't need improvement. They're there first. Okay, so since they are first, they more like the food. Okay, they're more likely to say they like the food. They're okay with the food. No, it doesn't need improvement. The next one, in the setting, how could the bias been introduced based on the way the question was worded? Now, there's two ways. Okay, first, some say it needs improvement. Well, that's going to lead, you would explain, and you got to be more detailed than I'm going to be on this sheet. You got to say, because it says some say it needs improvement. Oh, yeah. It gets you thinking it needs improvement right away. So that's going to create more yes answers, because they're just going with the flow and agreeing with the opinion of that first statement. But then the other thing, oh, it's going to increase the meal plan. That one is going to lead, I'm making a video, everyone, that's going to lead to more no answers, because people don't want their costs to go up. Okay, so there's two answers. You don't need both of them for that. You have to pick one if you're on the AP test. You say, how could it influence it? Well, the first part influences you more to say yes. Because if everybody's saying it needs improvement, that must be true. And people just go with the flow of stuff, and they should think through it. This is a terribly worded question. Increase the cost of the meal plan. Well, if it's going to increase it, I mean, I don't want to pay more, so I'd rather not do that. Okay. Number 3. All right, this is an old question. An apartment building has 9 floors, and each floor has 4 apartments. The building owner wants to install new carpet in each apartment. So he wants to put an apartment in all of them, but wants to see how well it wears before she decides whether to replace the carpet in the entire building. The figure below shows the floors of apartments in the building with their apartment numbers. 9 apartments indicate an asterisk have children. So you notice this one has kids. This floor, it's got a couple apartments with kids. This one has no kids, no kids, no kids, no kids. This one has a couple apartments with kids. This one has kids, and these have kids. I think I got all the asterisks in there. So the first, second, seventh, eighth, and ninth, they have kids. All right. For convenience, the apartment builder owner wants to use a cluster sampling method. So remember, the cluster sample, we talked about it. You just pick some of these in which the floors are clustered to select 8 apartments. So she would put numbers 1 to 9 in a hat, and she draws them out. Describe a process. So how do I draw this? Put numbers 1 to 9 in a hat. Draw 2. And you might be like, well, why are you drawing 2? Well, if I draw this one, that's going to get me 4 apartments. I draw this one, that's going to get me 4 apartments. Okay? Draw 2 after shaking. Remember to shake the hat. And evaluate those 2 floors, which is going to get you 8 apartments. That's doing a cluster sample. The cluster, you pick 2 of the clusters and you do a survey everybody in there. That'll get you 8 apartments. Okay. B, an alternative sampling method would be to do a stratified sample of 8 apartments, where the strata are apartments with children and apartments with no children. Stratified sample of 8 might include 2 randomly selected apartments with children and 6 randomly selected apartments with no children. In the context, give one advantage of selecting a stratified as opposed to a cluster. Well, okay, let's start with the cluster. With this last one, let's say the 2 numbers I pick happen to be 4 and 5. I'm not going to get any apartments with children. So with the cluster, I could miss apartments with kids. Okay? Then the other one says 2 apartments with children and 6. Still going to have 8. But here, with the stratified, if I take instead the apartments like 92, 93, 84, 73, 74, 23, 22, and 11, and I put those 1, 2, 3, 4, 5, 6, 7, 8. I put those 8 in a hat, and then I draw 2. I'm going to get 2 that have kids. And then I put the other ones, what we have, we got 36, so there'd be 28 apartments that don't have kids, and I picked 6 of those numbers randomly. With the stratified, the advantage is I will get, or I will guarantee, representation of both types. Now, I don't write everything. You have to listen to what I say, but if this was an AP test question, you got to make sure that you write those things out and explain them. All right. Number 3. Alzheimer's disease results in a loss of cognitive ability beyond what is expected with typical age, and the local newspaper published an article with the following headline. The article reported that the study tracked the medical histories of 21,123 men and women for 23 years. The article stated that for those who smoked at least 2 packs of cigarettes a day, the risk of Alzheimer's disease was 2.57 times the risk for those who did not smoke. Okay? So here, what's the explanatory variable and the response variable? The explanatory variable is smoking. Do you smoke cigarettes or not? The response variable is development, or the percent of time you develop Alzheimer's. Okay. So it looks like it's higher for those that smoke. Is the study observational experiment? And again, this is going to be observational, and it always will be because people choose to smoke. But one of the things you got to recognize, so we might see the correlation, but it's not necessarily caused by smoking. Now, we might say, well, I bet it is. Well, honestly, I bet it is too. Okay. But we don't have the proof. We can't say it for sure is because there's so many other things. People who choose to smoke, maybe they eat worse. Maybe they don't exercise. Maybe they don't brush their teeth. Maybe it's any of those factors that are causing it. Maybe they drink more, whatever it might be. Okay, exercise status versus no weekly exercise was mentioned in the article as a possible confounding variable. Again, maybe people who smoke, they don't exercise because, they're out of breath because they're smoking. So it says, explain how exercise could be a confounding variable. So maybe, you can always put the maybe, people who smoke also don't exercise. And it is the lack, is the lack of exercise causing the Alzheimer's. Okay. So hopefully that's some of those reviews of all those things. You might need to look at those terms again, but we'll end the video there. Thanks for watching.